Hey everybody, welcome to a new video. This is not an Emacs video, or if you go way back, a Halloween video. This is an kind of an advent of code video. It's a video that I'm using to talk about some things that I wanted to blog about, kind of one of my education rants, but I want to do it around advent of code. You'll also notice that you'll see that this is my zoomed in on the me part of the image. I'm now deciding to finally, ooh, we can change views, okay, and we can transition back. So we're doing this for the, for OBS Studio. I figure I should do that, just since it'll be a little bit more talking in this video. So what is this video about? Well, whenever I do an advent of code problem, and I'm doing pretty well so far, you can't really see this on the screen, or, well, I can do this, yeah, you can see that I just haven't finished this middle part of number 3. I have to, I'll get to it at some point, but I'm doing okay. I'm doing okay so far. I'll probably fall off in a couple of days. I'll be traveling this weekend. I'm going up to Michigan to see my son in the UMGAS production of Princess Ida, which I'm really looking forward to. But I'll try to do as many as I can. But what I like doing is, once I solve a problem, I go over to the Advent of Code subreddit and I look at the solutions thread, and I get to look at other people's solutions. And it's cool because you can see how different people approach the problem. And it got me thinking that our solutions are sometimes dictated by our tools and the way we think about problems. It's kind of like if you are trained as a functional programmer, you solve problems in certain ways. If you're trained in an imperative style, an object-oriented style, and that dictates your solution. So when I look at a solution from a beginner Python programmer, I see things that I might think are clunky. It's a great solution for them. They're less experienced. But I'm like, oh, this could be much more elegant doing it in another way. And then I'll look at somebody else's solution who's much more experienced and stronger than I am, and I'll be like, whoa, that's beautiful, that's elegant, or I don't even understand how this person is doing that. And if you look at different languages, you see totally different approaches, and sometimes the tools that you're trained in, they're expressive in different ways, and they lead you to create in different ways. It kind of reminds me, and this just popped into my head now, Close Encounters of the Third Kind, when they're all creating images of Devil's Tower, and I think that's a long time ago, and one of the characters had painted it and only saw one view of it because that was her medium she painted, but the Richard Dreyfuss character, and this goes back to when I was a kid in the 70s, I don't really remember, he sculpted the tower, and so he had a view all the way around it. His tool gave him a different expressive view, and I think it's the same thing with programming, is that the tools that we're trained on let us solve problems in different ways. And it also got me thinking about the whole CS education movement, because that's my thing. And within the CS education movement, there's a little bit of a there's pushback that it's not coding for all. It's not coding, because coding can just be kind of this mechanical code monkey thing. Here, code this up, and not necessarily a creative thinking, problem solving process. And I'm certainly part of that bandwagon where it's computer science and it's thinking and it's problem solving and it's creativity, but you also want to remember that the tool is what you're doing the creating with in a lot of cases. Maybe not all the cases, but in a lot of cases the tool is what takes your idea and makes it into a reality, and that's why the tool can be very important, particularly in terms of and if it's a practical tool. If we have our kids in our class and we train them on all these wonderful ways to think, and we're building these creative problem solvers, and if we give them a tool that isn't expressively creative in the next phase of their life, it's kind of a dead end. It's a toy they can play with. But if we give them tools that they can actually then leverage for greater good later on, that's kind of cool. Maybe that means they'll be able to write some scripts for their Google Docs to empower them in some way, or do some analytics in Python, or whatever it is. So the tool is important, and knowing the vocabulary in the tool is important. So yes, it is the problem solving, it is that mental aspect in one hand, but the other hand is also having the practical tool by which you can bring that concept to life. So let's jump in and let's take a look. Let's first look at problem 6. And problem 6, the idea is we have, let's switch the views. I forgot to do this last time, which screwed up the video. So this is the problem 6 problem statement. And the idea is we have these memory banks with numbers, and how many blocks are in the numbers, and the first one is 0, 2, 7, and 0. So if we come over here, we have 0, 2, not 9, 0, 2, 7, 0. And then what we do is we have to identify the biggest one, so that's 7 in this case, and we remove it from our data set. And then what we do is we kind of do like a Mancala action. We go through this so that we distribute a 7, 6, 5, 4, 3, 2, 1, 0, each time adding 1 to its space. So that's going to leave us with 2, 4, 1, 2. And that's our next situation, our next configuration. And then we look at the largest one, and that's 4, and so we pull out the 4, and I'm just going to put the 7, what was this originally? 0, 2, 7, 0. And then we do it again, and that gives us 3, 1, 2, 3. And then we pull out a 3, and the problem says if you have 2 of the same number or multiple of the same number, you pull out the largest one that occurs first. And then you have to go over and over and over again, excuse me, until we get a configuration that is duplicated. So if we eventually get to 0270 again, we're done, or 2412 or 3123 or any of the ones that we can come back later, then we are done. And the question is, the problem statement is, how many steps does it take us to get to that? So that's our problem, and we'll talk about a solution in a second, but first let's get the data. If we look at day one solution, which I wrote up a couple of days ago, you'll see that I opened, I read, I stripped, and then we did all these things with it. But if you're a more experienced Python programmer, you can kind of do these things a little bit more easily. So I'll open day6.text, and day6.test is this little test data set with 0270, and day6.text is my actual problem input. And then what we're going to do is we'll read the data, we'll strip the data, and we'll split the data. So we're just going to do that conversion to to move it into a list, and we'll just print L for some debugging, and we see down here that we get it as a list, except it's a list of strings. So if we know Python, we can use a list comprehension, which does the same thing here, but if we just apply the int function there, whoops, let's run that again to look at it, we now see we have our list of numbers. So so just here, knowing the language, we can be expressive in a different way. And because I like, when I do Python, I always think in terms of these list comprehensions, and about, it makes me think about solving problems in a different way in terms of massaging data sets, kind of more in a more like filtering and mapping type things, even though it's a different syntax. So the idea from this problem is I have some type of loop where I have to move from condition to condition to condition, each time doing that Mancala action until I get to an original condition again. And so to start with, this is where it's where knowing the language as part of your tools shapes your thinking. It's like when you have a little kid who's having a tantrum, and it's like, use your words. They may not have the words yet. So if you're a novice computer scientist trying to solve this problem, if you just know coding, this might be intimidating. But if you're experienced, you might take it for granted. Your brain just says, I have a state, and I want to see when I get back to that original state. The state is these numbers. I have my endless loop. Sorry about that. Don't want to run this with an endless loop. I have my state. This is a state. And I want to keep transitioning from state to state. So, think about a graph, transition diagrams, state diagrams, finite automata, all that stuff. But that all just immediately pops in my mind as a computer science guy, because I have those mental tools. I have that problem-solving technique. So I'm thinking of this whole thing as, we just have to keep going from state to state to state until we get back to a state we've already seen. So we're going to have to transition states, and transitioning states is pretty easy. So we'll actually put that part in first. So we'll find the largest of our list. We'll find the index of the biggest, take it out, and then we'll sorry, make our temporary index to loop through. And there we have it. So basically this is we're going to grab the biggest, find its index, and right here, just by knowing the language, I can think about this problem at a higher level. So this is, again, where knowing the tool lets you think of the problem in a certain way. If I didn't know about that max function, I'd have to think about looping through the list. But because I know the max function, I can just think about it as pull out the max, get the max, find its index using the index method, pull it out, and then I can do the Mancala thing here where I loop through and do this. But now the problem is, how do I know if I get to a situation where I was at before? And when I looked at the solutions on the Reddit, I saw some interesting ones where people would put things in lists and arrays and stuff, but to me this screams out dictionary. So what I'm going to do is I'll make an empty dictionary, call it D, just what the hell. And what I'm going to do is I have to store a key in this dictionary, but I can't use my list as a key. But what I can do is I can turn my list into a tuple, which can be used as a key because it just can't be changed like the list. And and this is, again, knowing the language makes things very, very easy. And since I want to count the number of steps, I can say that I'm currently on step 0. So very simply here, I can just say D sub key equals step, and then step equals step plus 1, add 1 to the step, each one is the next step. And at the very end of this, I can say my new key is a tuple for my new list value. So here the idea, just to step through it, is, and I don't want to go forever, I want to go while the key is not in the dictionary. So we start out where the dictionary is empty, so we come in here, we put in our first, we put in a, well, we actually put in, actually I originally put in a 1 in here. We put in a 1 for the first key, so now it's in the key is in there. That state is in the dictionary. We go to the next step, we do the Mancala thing, make our next key. That key is our second state. If it's not in the dictionary, we put that in, etc. And then at the end of the day, we just print out our steps, or step. And that gives us the answer, which indeed was the right answer. Now, part 2 of the question was a very simple change, which was why it didn't want to know how many steps until you got to a state again, got to a situation you saw before. The question actually was, how big is a cycle? So if you had a situation like this, where you had state A to B to C to D to A, well, in this case, the cycle is the full thing. But if here you went back to C, let's go to D rather, to A, the cycle is the full thing. But if we go back to C here, this means that our cycle is just C to D to C. It's shorter. That's the actual repeating part of this problem. But this is really easy. All we have to do here is, instead of putting 1 into our dictionary, we can say what step we found the key the first time. And then we can just print out the current step minus D sub key. And then we got our answer there, and 113.137 is the correct answer, 103.7 is the other correct answer, and that is it, and we are good to go. So here, because of our knowledge of computer science, our theoretical knowledge, we have state machines, we have a solution very simply, or even things like this going through the list repeatedly with mod, another idiom in the programming language. I posted about programming idioms a while ago. But then we have this way that Python lets us think about the problem with the dictionary. If you are coding this as a neophyte C programmer or C++ programmer or C programmer, certainly where you don't have dictionaries, you're going to go about this in a different way. So that's a good example, I think, of this, and just something to think about. So I also wanted to look at another problem here. I wanted to look at problem 4 as well, because it also is another nice example of being able to think about the solution, shaping the solution based on your training with specific tools. So I'm just going to erase this here. I'll just work in this buffer. All this code is up on my Advent of Code GitHub repository if you want to grab it. But this problem basically said we have all of these lines, and each line is a bunch of words, or words in lowercase, and they represent a passphrase. And a passphrase is valid if none of the words repeat. So here none of these words repeat, so it's valid. But here AA and AA repeat twice at the beginning and end. It's not valid. Here none of them repeat because AAA is different from AA, so also valid. So how do we do that? So let's start out again, and we'll start in, and the question says how many are valid in the steps, so we have to build a sum, and then we're going to, the 4.txt is the name of the file, and I'll do a read line here, and then we'll say L equals line.strip.split. Do I have a text? Well, let's look at the whole thing. So you'll see this is the whole shebang here, everything. But that's going to give us L being a list of strings, something like, AA, BB, CC, etc. And so now what we have to do is, this is going to be a valid passphrase. Each line is going to be a valid passphrase if there are no duplicates. So how do we do that? So this is again where thinking about the language makes sense. So you might do something with a dictionary like we did day 6.py. Here, make a dictionary. This is the solution this that we just had up. Make a dictionary, and then each time we see a word, put it in the dictionary, and then if it appears in the dictionary again, we know we've seen it again, there's a duplicate. But there's a much easier way of doing it. And it's based on the idea that in Python, we have the idea of sets. So if we have a list, L equals 1, 2, 3, 4, 5, 5, 5, 6, 4. So this list has multiple 5s and multiple 4s. If we look at it as a set, the set takes away all the duplicates. Set's just membership. And so this leads to just such a trivial solution here. If the length of the list is equal to the length of the set made from the list, then S equals S plus 1. And there we have our answer. Really easy, if we understand that our language has the concept of sets. Now, that's part 1, and that's great. And that was really easy because of this set operation, and we think in those terms if we were trained to think in those terms. So the second part here is valid passphrases are not only if there's a duplicate, but if there are any, if the words can be anagrams of each other. So here, in this example here, I don't know if there was one. That's a valid passphrase. This one is not valid because these words are just rearrangements of each other. They're anagrams. And so at first you might read this and say, oh man, that's hard. But it really is pretty easy. And the reason why it's pretty easy, so if we go back to our Python buffer, if we have, if we have a list, A, B, C, B, A, C, these are anagrams of each other. Let's put that into L. But we don't actually care. We don't have to check to see if the anagrams match. If we can put them, all of our words, into the same form, then, in an easy form is sorted. So we can just do something like this. We can just take our list and say, let's convert each of the words. That's going to be X sorted X, or X in L. And notice how that converts them both to ABC. And so now they're lists of a simpler form. And what we can do if we want, just to be stringy about this, is we can join them. And again, this is knowing the Python. And now we've converted them all into that sorted form. So even if, if our list is B, C, A, B, A, C, ABC, 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 and now we can compare them using the same code as before. So all we have to do here is basically just do that little switch. And we actually don't need to turn it back into a string. I just did it so I could print it earlier on. And then we have our solution and we're done. But again, because we can think of this, we're thinking about solving this problem in a Python-y way, or not a Python-y way, but these tools let us think about doing the list comprehension, sorting the data sets, etc. It leads us to a particular way of solving this. So I've rambled on now for a little while, about 20 minutes. So I think that's about enough. So I hope this makes some sense, what I'm trying to say here, that, one is that we do want to consider the tools that we're using to teach, because they do shape how the students solve problems, if your only tool is a hammer, that type of thing. And also, if we're giving them some practical tools, then they're going to be able to leverage these in some wonderful ways. So, I hope this goes, I hope this makes sense. I hope you enjoyed this. I will put this up with my blog post now. So, yeah, enjoy.